Hi, welcome back. In this specific session, I'm going to walk you through one-way ANOVA. ANOVA is also known as analysis of variance, or it is known as F-test. Why it is called as one-way ANOVA? Because we are going to deal with only one independent variable under the study. When to use ANOVA and when to use a t-test. T-test is used to compare the means of two groups are same or are they different. For example, let's say in a class, we have got the boys and girls. We are more interested to see that whether the scores of boys and girls of the same class are same or are they different. When you want to do the study, then t-test is the most appropriate one. When to use ANOVA? As a trainer, I'm adapting three different methodology to train the people. The first method is going to be on a traditional classroom learning where I do the lecture and people take the notes. Second level, I use a flipped classroom to well in advance give them the videos and the required theoretical material they learn. In the class, they solve the problems. Third one, I'm going to implement a project-based learning. The means of the three different learning will be the same for the learners or will they be different? This is what we will do it in ANOVA, which means in simple term, when you have gotten at least three or more than three, we will use ANOVA. Let's solve a problem here. We are presented with a study where a researcher is interested to find out how the different departments within marketing is perceiving the corporate ethical value. Here, three groups are taken into consideration: marketing manager, marketing research, and advertising. When you look at the value, you can clearly see that marketing managers, the least score is 4, moderate is 5, and the highest is 6. In marketing research, the least is 4 and the highest is 5. The advertising, 5 is the least, 6 is the moderate, 7 is the highest. Which means we can see the perception of the corporate ethical value are not the same across the three different groups. To prove this, statistically, we have to solve it. So to solve this, first level, I have taken the hypothesis where the perception of the corporate ethical values are same, which means marketing research, marketing research, and the advertising department feels the same way. Alternatively, marketing managers, marketing research team, and advertising do not feel the same way. Now, which one we are interested to prove? We are interested to prove the alternate one. That is what in the calculation we have seen. So to do this, we have to solve it. There are only 5 steps that's involved in solving one-way ANOVA. It is pretty simple and straightforward. First, we need the correction factor. Once we have the correction factor, what is the total sum of the squares? How much of the variation that is available in the entire data set? And find out what is the sum of the squares between the samples, or this is known as sum of squares between the treatments. Calculate SSC, then with the degrees of freedom, finally we will perform F-test. These are all the steps that's involved. I'll walk you through one after the other. As for the treatment, how many treatments are here? 3 treatments: marketing research, marketing manager, and advertising are equal to 3. What is N1? 1, 2, 3, 4, 5, 6. The count of the samples inside every treatment, 6, which means N2 equal to 6 and N3 also 6 because they have got an equal count. What is the total number of samples? There are 3 treatments. In every treatment, we have got 6 samples, put together 18. Once we have done with it, next level, we need T for the correction factor. Correction factor is used to isolate the real variation from the variation which has happened by the chance. We are going to take the summation of x1, x2, x3. Summation of x1, 30. Summation of x2, 27. Summation of x3 will be 36. This is the first step. Add 30 plus 27 plus 36, which will give us 93. Calculate the correction factor, which is the T raised to the power of 2 divided by the total sample, which is 18. 8649 divided by 18, which will give us 480.5. Correction factor is finished. Next, we have to calculate SST. SST will give us how much of a variation is available for the entire data set. To calculate the total sum of squares, we have to square each and every one of the sample, which will become 36, 25, 16, 25, 36, 16. 25, 25, 16, 16, 25, 16. 36, 49, 36, 25, sum it up. 154, 123, 280. Summation of x1 square, 154, plus 123, plus 218, minus, what is the correction factor? 480.5. The total sum of squares will be 14.5. Next, we need to know how much is the difference between the treatment. To do this, x1 is 30, n1 is 6, raised to the power of 2, plus summation of x2 is 27, raised to the power of 2 divided by n2 is 6. Summation of x3, 36, raised to the power of 2 upon 6 minus the correction factor 480.5. This will give us 487.5 minus 480.5, which will lead us to 7. The variation between the sample is 7. We got variation between the sample. We need to find out what is the variation within the sample. Do they have lots of differences? If the variation is too much high within the sample, we can say it has just happened by the chance. We have found the variation between the sample. Now we have to calculate what is the variation within these samples. Are the chances of something occurring due to a chance, or is there a real difference? Only based on that we will be able to evaluate. The difference in the perception has happened by the chance, or really the people have gotten a different opinion about the corporate ethical value, can be computed only when we have the sum of squares between and the sum of the squares within the value. Within is also known as sum of squares for error SSE. What is the total sum of squares? 14.5 minus what is the sum of squares between? Either we call this as a SSB or we call this as SSTR, between the treatments or between the sample. Sum of squares between the sample stands at 7. So the real difference is within the sample 7.5. Finally, we have to calculate the degrees of freedom. Then we can start plugging in the values. There will be 2 degrees of freedom, one for the treatment and another one for the sample. How many treatments are here? There are 3 groups. 3 minus 1 will give us 2 degrees of freedom. And how many samples we have gotten? 18 samples are there, minus the treatments is 3. So put together we have gotten 50. These are the major calculations. Now, based on these 2 scenarios, we will be able to fill up this table. In the table, within sample and between sample, the numbers that you see is a mere column number. Between the sample is 7. Within the sample is 7.5. When you sum up these 2, you will get 14.5, which is the total sum of squares. What is the degrees of freedom for between the sample 3 groups? Minus 1, which had given us 2. And for the sample, we have gotten 15 degrees of freedom. Now we need to divide the second column by the third column. 7 is the sum of squares for the between, divided by 2, 3.5. 7.5 divided by 15, 0.5. Now, next level, this is 4th column first cell, 4th column second cell. For calculating F test, we need between variation, phi within variation. This is what we are going to perform in the test statistics. F equal to What is between variation? 3.5 by what is within variation? 0.5. F equal to 7. F calculated value, F table value. F calculated value stands at 7. Table value we need to find out. This is the F table value. You have 2 degrees of freedom, numerator and denominator. Numerator is always for the treatment and denominator is always for the sample. Degrees of freedom for the treatment, it's 2. What is the degrees of freedom for the sample? 15. The intersection value is called as F value. The intersection value is 3.682. F table value 3.682. The table value stands at 3.682. What is the significance of the table value? The rule card is F calculated value is greater than F table value, except H1 F calculated value is lesser than F table value, except H0. This is the rule card. In our case, to prove our alternate hypothesis, we need minimum of 3.682. If our calculated value is going to fall lesser than 3.682, we will accept H0. Starting from this point until this point, it will be for H0. But if the value is exactly on 3.682 or thereafter, we will accept H alpha. Now see what is our calculated value? 7. 7, is it going to fall within this range? No, because 3.682. This is somewhere going to be towards the end of the tail. So what are we accepting? We are accepting H1. Since our F calculated value is greater than F table value, accept H alpha or H1. What does it signifies? There exists a difference. There exists a significant difference in the perception. Had the value been lesser than 3.682, we would have accepted H0. Yes, I can hear that. It is so easy. I'm sure you have enjoyed the video. Should you have any doubts, please post it in the comment box. I'm happy to answer it. Thank you so much for joining me. This is Karpakam signing off. See you in another video. Good day.